This is the second video of the chapter 3.2, solving linear equations by substitution or elimination. In the previous video, we did a summary of the three methods. We're going to do substitution right now. So substitution is best used when one variable is already isolated or solved for. And you can see in this instant that we already know what x equals. X is equal to y plus 1. That means in the second equation, I can substitute that x value for y plus 1. So I'm going to rewrite the second equation, negative 2. Instead of the x, I'm going to leave a hole to plug in my y plus 1. And then I'm going to actually solve for y. So I'm able to substitute the value of x, which is y plus 1, and now I can solve for y. So I get negative 2y minus 2 plus 3y equals 2. This would give me y equals 4. Now I'm not done. Once I've done that, I need to substitute this value into one of the original equations. It's very easy to put it in the first equation because x is already solved for. So I get 5 is equal to x, or x is 5. So the point of intersection is 5, 4. This is the point that satisfies both equations, so it is the solution to the system. That's substitution. Elimination is best used when you've got both equations in standard form, ax plus by equals c. Notice how the x's are lined up, the y's are lined up, and the constants are lined up, as well as the equal signs. So we're ensuring that they're lined up. We're going to multiply as needed to create an opposite coefficient. So you can see here that the y values, 6 and negative 3, I could easily create an opposite coefficient, a y coefficient, by multiplying the second equation by 2. And remember, you can do this. You can multiply, you can do anything you want to an equation as long as you do it to both sides. So I'm taking the second equation and I'm multiplying both sides by 2. Common mistake is people forget to multiply both sides of the equation. I'm just going to rewrite the first equation, and you can see that the equations are now stacked. I have created now opposite coefficients. So when I add these together, the y values cancel out. I get 2x plus 10x is 12x. Those are like terms. 176 minus 8 is 168. And I divide both sides by 12, so x would be 14. So once I have my x value, I'm going to substitute it into either of the original equations. It doesn't matter, because when I put 14 in for x for either one, I'm going to get the same y value because it is the solution. So I have substituted into the first one, and now I'm just solving. So I get y equals negative 6. So remember, the point of intersection has to be written as x comma y equals 14 comma negative 6. Now all these have worked out as integers. Don't think you're always going to get integer solutions. I will likely put a couple on the quizzes that are fractions. Moving on to the last page, we're going to quickly run through this. Systems of linear equations can have exactly one solution. Infinite solutions, remember, that's called consistent. Or no solutions, that's called inconsistent. So what happens when you have a consistent infinite solutions, or when you have inconsistent no solution? What happens when you do elimination? Well, the variables will cancel out, and then you have to look to see if the final statement is true, then they're infinite solutions, or if the final statement is false, then there is no solution. We did this before when we solved equations. If the variable canceled out, we looked at the final statement to determine if it was true or false. If it's true, it's infinite. If it's false, it's no solution. So in A here, you can see I was able to create opposite x coefficients. I rewrote the red equation here. I took the second equation multiplied by negative 8 because I wanted to create opposite x coefficients. I wrote that here. When I added straight down, the x and the y terms canceled out. Now that doesn't mean I have nothing left. I have the value of 0. And then on the right hand side, I also got the value of 0. 0 is 0. That's a true statement. So you can also see at this point that these are the exact same lines. So there's infinite solutions. These are the exact same lines, so every point on their line is a solution. So if we look at B, I'm going to create opposite x coefficients because I can easily create a negative 6 in the second equation. So I'm just going to go ahead and rewrite the first equation. 6x plus 3y equals negative 12. You guys, you can also create opposite y's. It doesn't matter. I'm just going to stick with the x. If I multiply this second equation all by negative 3, I will get negative 6x minus 3y equals positive 18. And then I'm going to add straight down. The x values canceled out. Oh, the y values canceled out as well, so that's 0. But it's very important to see what's on the right-hand side, and that's 6. This is a false solution. False. So this means there is no solution. These lines here are parallel. You can also tell that when at this point, see how they look exactly the same on the left-hand side, but that means they have the same slope. But on the right-hand side, that means they have a different y-intercept. So that is special cases. So problem set 3.2, you should begin working on that, and we'll be doing it, finishing it in class. It will be due the night of our next class. Hope this helped.